Then basically, I have stressed a lot this idea that you can produce in different ways, because it's a very important concept, que es este, the marginal product, which basically shows you this infinitesimal increase, or how much production increases, overall or final output increases every time you use one more unit of a specific input. So you're probably seeing just a blank sheet of paper. An alternative way of seeing this is that the marginal product of a particular input is how much does that input, using extra units of that input, increase production. Básicamente es cada extra trabajador, cada máquina extra, cada material extra, cuánto más producción me va a permitir alcanzar. That is the definition of the marginal product. Basically, how much will production of my final good increase whenever I decide to increase the use of any of the particular inputs of production. For the sake of our class, the way you calculate it beforehand or a priori is with this formula que está ahí en el second bullet of the slide, which basically is the marginal, in this case, is the marginal product of the first input, is the change in the final output y when you increase one more unit of x1. No? It's literally the partial derivative of your production function with respect to the that x1 input. If you wanted to calculate the marginal product of the fourth input, it would be a very similar idea. It would be just how much does the overall output y change when you increase one unit of the fourth input x4. So it would be the same, the partial derivative of the production function with respect to that x4 input. Questions regarding this formula? So something very important to know or understand is that, and this is key to the question that was asked a couple of seconds ago or a minute ago, is when do you calculate the marginal product? How do you calculate it? We answered how do you calculate it with the previous formula, but when do you calculate it? It's really important because in different moments in time, the marginal product will be different. And that depends on the particularities of the production function you're working with and the units of that particular input. So many times, the more and more you increase the production of a good via the increase of one or several of those inputs become not as effective as they were at the beginning. I briefly mentioned this the other day, talking about how when you hire new workers, maybe the next workers will not be as good as your original ones. The original ones were probably the best you could find at that specific moment, but continuing increasing the overall number of workers can be hard because not all workers are the same. So I place an example of a restaurant, or basically business, and cooking dinner as this final output. So imagine you are the owner of a restaurant and you just opened your restaurant, you had a couple of good months, and you have decided to increase the size because you have greater demand of your customers. You want to increase the size of your restaurant such that you are able to satisfy all the customers that come at once at night or at lunch or whatever. But if you are not able to move or increase the size of the kitchen, then you come up with this problem as it looks here. So imagine that the kitchen size is fixed for your restaurant. So to satisfy all those customers, you need to hire a couple of cooks. So every time you hire a new cook, it has a positive but also a negative effect. So the first person that you hire obviously his or her help is very useful, because if you're on your own, you're the chef, and you're on your own, you will not be able to cook all of these meals for like 10 people or 20 people or however number of customers you have at the same time. So you need extra hands and extra cooks that work for you. So the second person that you hire is very useful. Then, sorry, the first person. Then the second person obviously helps you out, but every cook or every chef within the kitchen can do a couple of meals at the same time. So very rapidly, it may be the case that you have, as the expression in English says, too many cooks in the kitchen. And the moment you have too many cooks in the kitchen, actually it may hinder the performance of the original cooks or chef, because the more people you have, the harder it is to move within the kitchen and actually like get the things you need, because you have too many people, and suddenly that crowding out effect essentially hinders your production in such a way that the overall marginal product looks like this. So this is the marginal product, which is basically just a partial derivative of the production function with respect to the particular input, in this case, the particular input X. And as you start increasing X and you move to the right in the X-axis, sometimes the increase in the production, the Y-axis, as you can see at the beginning, the first cook you hire allows you to increase production, and that's why it has a positive and a steep slope. But the more cooks you have, the less each one of them adds to the overall production. A great example of this, where the marginal product is actually almost negative or zero, is Pemex. Pemex is a very inefficient firm, among other things, because it has too many workers in their different units, business units. For example, I did a research when I was working at a think tank a couple of years ago, and before the energy reform, I calculated the marginal product of Pemex, of labor of Pemex. And they were producing, I can't remember the number of barrels they were producing back then. Ha de haber sido como 2.5 million barrels per day. Right now, they're only producing 1.7 or 1.625 million barrels per day. But the point was that back then, they were producing like 2.5 or a little bit around that number. But they had 153,000, I think it was, workers within their entire facilities in Mexico. Todas sus oil rigs, their offices, their refineries, their different business units. And when you compare that to other firms, other oil firms in the world, for example, another state-owned enterprise like Statoil, the Norwegian state-owned oil enterprise, Statoil, who actually produces oil in different parts of the world and not only Norway, they are hired and they work in other countries. They are a global firm. They were producing only like half the number of barrels a day than Pemex was as a firm, not as a country in Norway, but Statoil only as a firm. So about half of Pemex production was the size of Statoil firm in 2012. But Statoil had only a fifth of, in the entire planet, of employees that Pemex had. So once you take into account that, the overall marginal product of Statoil was much higher than the one for Pemex, because Pemex had basically too many cooks in the kitchen. And every time you have more people, your cost increase, but your overall product not necessarily increases that much. So it's crucial that firms understand when they need to stop increasing production. And the key concept here, before we move on to the next slide, and I ask if you have any questions, is that any firm that wants to continue expanding their production, increasing production, they should only increase production until the point where the marginal product of a specific input you are increasing equals zero. So I'm gonna stop sharing this screen and share the Word document again to basically write that definition or modern definition, that particular point. At the beginning, the marginal product will always be positive, and it will start increasing, then probably plateau, and then continue to increase, but at a decreasing rate. And instead of increasing maybe 4 units your production, it only increases now at 3, and then only 2 units, and then only 1 unit. And the moment your production does not increase anymore, you have to stop hiring more workers, because every extra worker will only represent costs and production will not increase. This applies not only to workers. This concept of the marginal product equal to zero applies to every input you may have. Now, another thing to take into account, there's another concept that it's important. Similar to the marginal product, but it's not the same thing. The technical rate of substitution is essentially a rate of marginal products. As the formula reads down there, it's how much does the marginal products of different inputs, input 1 or input 2, change as you move them, basically. So it's the rate at which one input can be substituted for another. We have discussed at length over the last 2 classes, well, the last class and this class, that you can produce things with different input combinations. And you can start substituting one for the other to get basically the same level of output. Basically keeping that level of output constant, hitting your target production, la que quieres producir. Pero para ver cuál es la combinación óptima, what you do is basically you divide, or you basically see, you divide the marginal products, because every input increases your production, que es lo que veíamos con el marginal product, up until a certain point. So you want to be at the exact point in which you want to be. And that is the technical rate of substitution. That looks more or less like this. If the target production I want to hit is Y1, then the particular slope that you want to hit, it's the technical rate of substitution. It's what is the optimal ratio of the marginal products. For the purpose of this class, porque la mate es mucho más complicada y tardada, más que complicada, tardada, you will not have to do problems like this, donde me tienen que calcular el punto óptimo del technical rate of substitution, como si hacían en la parte del optimal consumption bundle. Because here there's no shortcuts, como si había en el otro, in the consumer side of things. So I want you to actually have this idea, but in a theoretical way. You use the technical rate of substitution to determine the ideal point at which you basically hire or get inputs. From all the inputs you may be using, the technical rate of substitution is this ratio at which you find the best place in terms of how that affects the overall production, based on the different combinations of inputs I could use. Questions regarding the technical rate of substitution. For many, many different industries that can be modeled with Cobb-Douglas functions or constant elasticity of substitution functions that represent convex-like preferences, we normally have a diminishing technical rate of substitution. So what happens when you have a diminishing technical rate of substitution is that fewer units, or with each fewer units of X1 available, X1 is the X-axis input, one has to substitute more units of X2 to keep the same level of output constant. Si yo tengo que hit a production target of 100 units, whatever I'm selling, and suddenly one of the inputs starts to become scarcer and scarcer because there's no availability in the market, or because I'm deciding to not use it at all for whatever the reason, I have to continue to substitute more and more units of the other inputs para poder, al revés, tengo que sustituir más unidades de este input que estoy dejando de usar para poder llegar al target. Let's go to the Nike example, Nike jersey example. If there is no cloth available, suppose there's only one cloth available. Suddenly, if there's a lot of scarcity, you clearly need to have a brutally efficient way of cutting the cloth para que con el mismo metro cuadrado, cada vez menos metros cuadrados que tengo de tela, pueda sacar la camiseta completa. At the beginning, remember that the 3 workers were wasting a lot of the material when cutting it. But if I introduced machines instead of the workers, y cambias un poco, you substitute one input for the other, you could be less wasteful and produce more efficiently. But the less cloth you have, the less wasteful you could be para realmente poder producir una camiseta. So you would have to basically start changing things within to actually keep the target constant. And that is modeled with this idea of diminishing technical rate of substitution. If one of these units, X1, cloth, becomes less available, you have to substitute more and more of the second units. Think of it in terms of cost, the other way around. If the cloth is scarcer and scarcer and scarcer because of some problem in the market, va a costar cada vez más y más dinero. Para poder hit your target, va a tener que gastar más de tu presupuesto or more of your budget into buying that same piece of cloth, which will force you to basically not hire as many workers or not buy or not rent as many machines, because you have to substitute the costs of those inputs to basically satisfy your cost function. Because if not, le va a incrementar el precio a tu producto, and as you increase the price, and you recall from the beginning of this class, you will lose customers. So we move to finish this concept before we head into the last part of this lecture, which is this idea of diminishing marginal product and diminishing technical rate of substitution. Diminishing marginal product means that every extra unit of an input I hire, buy, or use will produce a smaller increase in the overall output up until a time in which it can become negative. And diminishing technical rate of substitution means that each unit of the second input you give, it needs to be replaced with more and more units of the other inputs in order to produce the same output. Basically, this idea strives the fact that normally firms would want to have a more balanced way of production, that you can have sufficient workers to hire and you are able to decide how many you want, and that you can find all the machines you need, and that you can find all the inputs you need. Questions regarding these two things.